Programming Throwdown, episode 159, GraphQL with Tanmai Gopal. Take it away, Jason.
Hey, everybody. So we have an awesome episode here. I remember the kind of first time I saw GraphQL, and I remember it's just kind of a magical thing. We're gonna dive into it. I'm not gonna kind of spoil it or anything, but it is something that kind of really spoke to me. I think in general, when you look at the way that you can sort of design sending information over the web, I think GraphQL allows you to do a lot with very little. It's a really powerful tool, and I'm really excited to talk about it. A lot of people don't know about it, and so a lot of folks out there listening, this might be the first time you're hearing GraphQL. You might be thinking, "Oh, is this a new SQL or something?" No, it's very different. We're going to cover it from top to bottom, and to do that, we have Tanmai Gopal, who's CEO of Hasura, to cover it. So thanks so much for coming on the show, Tanmai.
Thanks for having me. Great to be here, Jason.
Great. Yeah. So, before we get into GraphQL, we always love to hear about our guests, like where they, kind of came from in their careers. What did you study? Were you coding on a Atari at 4 years old, or did you start getting into coding at 34 years old? What's the journey like? And what's the path that took you to Asura? So I'd love to hear more.
I started programming fairly late in my life in university. And I think till I was in university, I wanted to kind of do kind of more pure sciencey kind of stuff, which appealed to me more. And then during kind of like my pre-university years, maybe when I was 16 or 17, the idea that we've kind of been able to create a world that is entirely on our own terms, that is to a large degree disassociated from the natural law, right? Like you don't have to worry about physics. Like you're building a bridge. You need to care about like the wind and the earth, right? But when you're doing something on a machine, and we've kind of built this world of software and the internet, it's kind of insane how that happened. And so, and how that happened and how we did that was just like an idea that was stuck in my head, and I really wanted to find out how this was built. And that's the reason I wanted to then kind of study computer science. And so that's what I studied in university. I did my bachelor's and my master's. For my master's, I then specialized in, I covered a lot of breadth while I was in university on different kind of computer science topics. And for my master's work, I specialized in machine learning and computer vision. I did some research work that I sold off to the defense org in India.
Wait, so let's dive into that a little bit. So I think if and tell me if I'm not paraphrasing this correctly. So when you're doing your undergrad, it was in more of the hard sciences, and then for your master's, you switched to computer science, right?
No, pre undergrad, I thought I wanted to do more pure sciences stuff, but then when I had to choose kind of a work stream for my undergrad, I decided to do computer science.
Okay, got it. So what was that like? So, I think, I had a somewhat similar thing where I was pretty sure I was going to be in math, like a math major. And then I got to college and I went with computer science. And so, in your case, what was that like? Like, where did the mindset change and how did that evolve?
I think it was like this, just in terms of the amount of things that we are able to do as humans, it felt like we could just do so much more because we created kind of this world on our own terms, right? This abstraction on hardware that was software, right? That it's video games or code or the internet or whatever, right? So I felt like that's all I understood about computers. I didn't understand anything else. I'd used computers before, of course, and I'd played around with programming in school, I think once or twice, and it was very interesting. But then kind of that thing got stuck in my head because most of your school years, right, you're kind of studying, you're doing like basic physics and chemistry and biology and stuff like that, right? And that was very interesting. But I felt like from what I had studied to where the world was, there was a bit of a gap. And I wanted to kind of unpack what that gap was, right? It's like, sure, like we understand these electrons and things, and we understand like we understand electricity, we had semiconductors, and you kind of get in there, like you're kind of feeling that the building blocks are coming together, but there's still a little bit of a leap before then just transitions into this virtual world or into this thing, right? And so I really wanted to unpack that. How did that happen? That's the only thing I knew. That was the only agenda I had to kind of figure out how that happened. And that's kind of what pulled me towards studying computer science. Does that make sense?
Yeah, totally. Yeah, I mean, I have kind of a similar experience where I think if you look at math and economics, you build these models with a ton of assumptions, and they're relatively simple models. And then you can, like I'm thinking about differential equations here, but there's probably a ton of others. But then you look at the computer world, and I mean, when I was in high school, Half-Life came out, the original Half-Life game. And I remember seeing there was this demo where there were barrels. They basically made Plinko, Plinko from it's this game where you drop a disc and you have a bunch of pegs on a board, and the disc kind of bounces among the pegs and then falls in one of the buckets. And you assign points to different buckets. And it's a lot of fun. And so the Half-Life, when they were showing off the game, the developers basically built Plinko in the Half-Life engine, and they dropped one of these explosive barrels, and it just bounced on these pegs and went in a hole. That really, like, I got really enamored by that. It's like, wow, what a complex system that these, handful of folks just created out of thin air. It's just something really powerful there.
Exactly, right? And I kind of wanted to really unpack that. And then that's kind of what undergrad was like.
Oh, very cool. So you went to grad school, then you did a small company that was doing some work with the military. And then, yeah, what happened after that?
After studying, when I wanted to kind of figure out what to do in the real world, right? I think during those kind of last few years in my undergrad and then while doing my master's, I thought maybe I want to do research. But then when I did some research and I was like, nah, this is still too slow. I want like a shorter feedback loop. I want to be able to do something and then have impact. And so then what I did was I just kind of went into industry and started doing my own like freelance consulting initially in the space that I was in, and then kind of gradually just trying to understand and take stock of what is happening with companies across the world and what are kind of their key challenges that they're struggling with in terms of kind of scaling their ability to build products and build digital products and take things to market and stuff like that. And so for the next few years, I started a consulting firm, and I got together a bunch of folks from from university and friends and stuff like that, and built out a small consulting firm. And what we did was we worked with companies of all shapes and sizes, with like global like banks to tiny startups to brick and mortar companies building their first digital product and stuff like that. And during that time, what we kind of did was we built products for them. And internally, a few of us we had kind of like a platform team. And what we were trying to figure out was what needs to be done to make this whole process of building things faster. And the reason why we set up that platform team was because me and my co-founder today at Hasura in our previous company, we wanted to build out a small application. It was like a food e-commerce type thing, just for kicks. And I thought it'd be really easy to build. And and as I went through that process of developing the application, I got so angry. I got really, really angry. I was like, this is not okay. Like, this is just way too much work.
Yep.
This is like, we're doing too much work for doing. This was the time when we had like things like Ionic, and Ionic was just coming out. There used to be a thing called jQuery Mobile. I don't know if you remember.
Oh man, I remember that. It looked so janky, right?
Web components and Polymer, that like Polymer web components or something that Google was just starting to come out, right? Twitter had a framework called Flight.
Oh, that's right.
Yeah, so these kind of little things were just were just happening. But regardless, like it was a time of like tremendous amount of frustration, both on the front end side and the API side. I was like, we are just doing too much work. We don't need to specify so many things. I mean, computer science has moved on.
Yeah, I feel like in many ways, mobile is still frustrating. I think, on the web, for example, if you want to plot a time series on the web, you would just go to GitHub, you'd find a time series library, you would add it to your, package.json file, and you're good to go. There's solid documentation. With React, you have pretty good isolation among the different components. You don't have to worry about that. On mobile, it's still a mess. Like if you want to plot a time series on mobile, you go on GitHub, you find some graph package that probably has like 13 GitHub stars, you plug it in, oh, it's in Java and all your stuff's in Kotlin, and like now you have to deal with interop and everything, and it's like, oh, I can't render on the main thread, it causes an exception. It's just the experience is very painful. And so, that's the thing, that when these things started coming out, like Cordera, I think was one, Ionic, these things where you could take your website and put it on the phone, that was so appealing. But then, as you said, they were also super janky. You're in this kind of uncanny valley where it worked enough that people knew it wasn't a native app and they didn't like it. And it was totally frustrating.
Yeah, exactly right. And so I was like, we have to fix this. We're going to do something so that we improve this, and the number of developers in the world ought to be like hundreds of millions, right? It's still just tens of millions barely. And so it needs to be hundreds of millions for the amount of impact that this has. And the world is going there, right? We are on that trajectory. It's not like it's not going to happen. It is going to happen. How do we help accelerate that? What are the pieces of the problem that need to be solved to kind of make that unlock as systematic as possible, right? As systemic and systematic as possible. And the technologies that really appeal to me and that appeal to us in the founding team were things like, databases really appeal to us, and programming languages and compilers really appeal to us, because it's such a nice way of translating like a higher level way of thinking into a lower level abstraction that something like a machine can understand, right? And databases are such a brilliant example of doing that, right? Because if you didn't have databases, like you'll be reading and writing to files every time you wanted to build something, instead of kind of capturing domain models and saying, oh, I have a time series model, and so chuck it into a time series database, right? Or I have an unstructured data model and chuck it into a JSON database. I have a structured table with relationships, and that's my domain, and so you chuck that into a Postgres or whatever, right? So those things were really appealing to us, and we were like, something needs to be there to make this process easier. And so with kind of a phase of like a lot of experimentation, a lot of learning what companies and what the industry is doing. We were super early in kind of the cloud native ecosystem. We played around with Docker and Kubernetes, both when they were pre 1.0. We built the world's first Kubernetes operator. So that did like a tremendous number of super early in the GitOps movement as well. I had one of the first Git push to set up and deploy Kubernetes-based applications. I remember speaking at one of the first KubeCons. So did kind of a bunch of things to understand kind of where the industry is going, what kind of things are happening, what kinds of interventions are required. One of the other things that we also did during this time was also like understand what the gaps in learning are. And I remember we ran this course on Introduction to Modern Application Development, which we kind of just said, all you need is a browser and you're going to learn how just web application development works.
Wait, let's double click into that. So how did you get to running that course? Like, did someone approach you? Did you go to Coursera and say, I love your platform, or like whoever and say, I love your platform, let me put a course? Like, how did that happen?
I went to a professor that I knew in university who I quite liked. And I went to him and I said, hey, we should just do this course because like university doesn't teach it. So the university that I come from in India is a fairly famous university, and they do these. It's a part of a network of universities that do a lot of online courses.
Is this IIT? I've heard the word IIT before. Okay.
Yeah. It's an IIT, and so they run these online courses that like everybody, like a lot of people in India kind of use, which are usually more advanced engineering courses, right? And so what I said was, hey, let's do this course where we kind of introduce like modern application development, right? Because nobody really like it's not covered in the university syllabus, and people really want to understand it, right? It's like I'm using this google.com thing for search. What happens, right? Like how is this thing working? Like what are the layers here? What are the concepts here that come together to make this thing work, right? And then obviously gives people a feel for like writing a little bit of a hello world and then seeing that work inside of a browser. And so we put this course together. We built like a browser sandbox environment where you can write code and you can see a website go live. I think it became one of the largest Kubernetes clusters at the time. I think it had like a 700 node cluster to power this, because we had like 250,000 students in a year that went through the program. And that was fascinating as well to kind of take a look at and see this is how much people really want to learn. This is how much people really want to do and have agency and understand how these things work and then use it to build something.
Yeah, I feel like, just to double click on that, I feel like, I'm a big fan of university. I mean, I got a PhD. I really enjoyed my time there. But one of the things that it did not prepare me for is writing modern software at all. The code behind my PhD dissertation, let's say the PhD project or something, it was all just XML files. I was like by hand editing XML files to configure everything. And it's like, and even when I was writing all the statistics out, I was writing those in JSON and XML files and then trying to by hand look at it. And I remember at one point writing a Python program to like read in an XML file and compute the average of all the entries in the file. And basically, like, I could have probably graduated half a year earlier if I had just someone had just told me what SQLite was, or MySQL or whatever. Yeah, I had no background in databases. I had no background in networking, and I was completely ill prepared to build anything significant. And so yeah, what you're touching on is extremely powerful. And so no matter how like theoretical you are, just take the time to learn how to build a modern website or a modern app. It's so important.
Yep. And for everybody across the spectrum, right? I remember we had like some of the students who joined that course were people who were like professionals, who'd worked for a decade, 2 decades in a completely different industry, not even like technical or sciencey, and were just like, I want to build a thing, and I want to see what it feels like. And it's fascinating, right? Because like you can actually do it. Like you can convert an idea into a thing. It's possible today. So we did a whole set of things, basically, is what I'm trying to say, right? And of all of these things that we did, the piece that stood out to us the most was this idea that when we kind of take a step back, and this is around 2018, 2019, when we kind of take a step back and we look at where the industry is going, our hypothesis was that the data experience is going to keep improving. We were in a world in the 80s and 90s when the databases first came along, which became the perfect place to model your domain and then interact with your domain, right? That's what the database became. It said, instead of you trying to scroll around with files, why don't you chuck stuff into a table and then you have this amazing language like SQL to be able to query that database and interact with it, right? And that was amazing. And then we kind of went through this thing where the database companies became a little too greedy. Everybody wanted to buy an island or two. And they kind of really penalized, right? They really penalized people in the industry to start actually working and having business logic in the database and doing things like that. And so people wanted to start taking that outside of the database. And so they started building applications that would then interact with the database, right? And so you build applications. These applications, when the internet came along, became application servers and HTML, which became like the front end, right? So it kind of like went from one place where things would happen into two, into three, right? When suddenly you had the web as well. And then 2010 onwards, that like the third end of it, the web experience, the mobile experience became very rich because of the mobile kind of improvement that happened, and with the iPhones, smartphones, whatever. And that's kind of where products were getting built, right? And then we had these APIs in the middle, and then you had data stores. And those data stores were scaling for a long time, right? Like 2005 onwards, everybody was very frustrated, like my databases are not scaling. But then again, around 2015, 2016, we again reached kind of that point where databases figured out how they're going to kind of become more scalable. And we started seeing the first distributed relational databases. We started seeing the NoSQL databases also adding more database features, becoming closer to relational databases, but also kind of providing that kind of read-write performance at scale.
Yeah, that's an interesting story, right? Like, MySQL, Postgres were the biggest thing, and then there was a period where it was all HBase, Cassandra, and all of these type of efforts. But then it seems like we've almost gone back. Well, I think what it is MySQL and Postgres are so much easier to shard now that people have kind of gone back to that. And HBase is probably, just a less than 1%.
Yeah. It is still too low level, right? Because what is amazing about Postgres and MySQL is how rich they are and their capability and what you can do with them. They just weren't scaling. And then people figured out how to make them scale. And now, so we're back to kind of being able to use things like Postgres and MySQL, right? So when we kind of like looked at the data industry, right, we looked at the database industry, we were like, the database industry is going to keep figuring it out. We're in a place where you can now have a managed database. And if you choose your workload and you map your workload and a part of your domain, right? Whatever your domain is, you map a part of your domain and you choose the right kind of database for it, you'll get like really, really good scalability, right? It'll keep working for you for a really long time. Like you'll have to start kind of touching like Facebook, Google scale for you to start stressing out about your database. But short of that, you're probably not going to have to stress about your database at all. It'll just be a managed service that runs. You can say that it's very heavily transactional, or it's super relational, or it's time series or whatever it is, right?
Well, now there's even the serverless, like there's Aurora from AWS, where it's a completely serverless MySQL, and I don't even know honestly how that works because they have to reverse engineer your intent. It's like you don't really I don't think you even have that many knobs to tune, but just as your demand scales up, it sort of figures out how to distribute that load. It's remarkable.
Yep. And they separated. People started learning this idea of like separating compute from storage, right? And then really exploiting cloud, and that's how they managed to do this, right? And the OLAP ecosystem is improving. The time series databases and real time analytics databases have gotten really good, right? Whether it's like you look at the generation of like OLAP and data warehouses that really took off on the cloud, whether it's like Snowflake, BigQuery, Databricks type systems, and then you have like the real-time analytics versions of it, like whether you ClickHouse and Druid and Ignite and Simple Store. It's amazing, right? Like there's no one database that's going to do everything, but you can take bits of your domain and chuck it onto the right data stores, and it's great. It's phenomenal. It works.
Yeah, and ClickHouse is completely open source, so it really kind of took the BigQuery Snowflake ecosystem and now it's like almost becoming a commodity. As soon as someone open source comes on the market, it completely disrupts everything.
Yep, exactly, right. And so we kind of were getting the sense that this is going to happen. So this experience is going to be amazing. So kind of when you're thinking about building a product, right, you're like, okay, so the data stack is going to work. That's great. And it's going to keep improving. Phenomenal. It's going to keep fragmenting. It's going to keep improving, but that's great too. We look at the product building side of things, right? When you're looking at your JavaScript frameworks and whatnot, we started seeing early signs of like React is becoming very popular. The meta frameworks in React were just starting. And it looked like that experience was also on its way to becoming. There was this continuous increase in complexity, right? As always, and fragmentation. But that experience was getting better, and at least if not, at least no, all of us in web development think that we're still doing a little too much work on that side of like building the product and like trying to wrangle like 10 JavaScript libraries to doing something and whatever. But it is continuously becoming better. And at least what you have there is what is happening is that the agency is really high, meaning that you're kind of able to go build a thing and then you're able to refactor that and change that and do something else and like keep evolving very quickly, right? Like your best practices evolve quickly, but then you can start using them in production also pretty easily, which is great because if that's happening, that means you can keep evolving, right? And so you don't need to do much. And so the product building experience was getting great, right? The part that sucked from our point of view was the piece in the middle, which is this piece of API development, right? Because we're like, this API development piece, our gut sense was that we aren't adding too much value here, right? There is something that needs to be done, right? But why is it not product and data? Why is there this middle layer of the API, right? And so we kind of took a step back and said, what if products that are end user facing, right? And that might be running on your device or your browser or being run in a different organization or a different team in my company is running this product. Why can't that product speak to my domain data directly? Why? Like, what's this thing in the middle?
The thing that has been there for a while, and I'd love you to burn this straw man down, would be ORMs. Like I think the superficial answer is, oh, we've had ORMs forever.
Correct, right? We've had ORMs forever, and I think even with ORMs, right? When you think about it, the question really is: so you have a front end application, right? You have a bank like an application. It's like your bank app, right? And your bank app needs to do a transaction or whatever, right? Why can't the bank app talk to the bank's database directly, right? Why can't it just speak in SQL? That's what we used to do. That's what all developers know, right? Assuming it's a SQL database. So why not just do that? Why does this app then speak to an API in Rails or Node.js or Python or whatever it is, right? And then we have an API, it speaks in HTTP and JSON, and then you have an API, and then this API thing uses an ORM, like you said, right? And then that ORM then speaks to a database. Like the ORM is like a translation layer so that you can translate like Python concepts or Node.js concepts or TypeScript concepts into SQL, if it's a SQL database, and then it runs against the database. But why do we have these layers in the middle? If is it worth having these layers in the middle rather than just telling developers to just use SQL, right, to interact with it? What's happening? And so when we broke this down, we said that, or the hypothesis was, the only thing that is happening at the API layer, like, but the only two things that necessitate this API layer is one, a performance problem, which is that databases don't handle high concurrency really well. They're getting better, but they're still not able to handle like 100K, 200K kind of concurrent users. They prefer having 1,000 concurrent connections as opposed to 10,000 concurrent, like 20,000 concurrent HTTP users.
Yeah, let me actually just if you could bear with me, I'll dive into that a little bit, give a little detail for the audience. So, when you have this API server, it's handling tens of thousands of requests, maybe thousands of requests a second even, but it has a relatively small pool of database connections. And so it might be that a lot of those requests could be waiting for, a spot in that pool, but that keeps your database from blowing up.
Exactly, right? And you multiplex them, right? So you realize that 1,000 of these requests are kind of requesting the same data, but you keep the connection open and you pipeline those concurrent requests over the same connection, right? Because databases like having long connections that are open for a long time, and they do a lot of optimizations with that. They don't like it when you frequently disconnect and reconnect and do things. It kind of breaks some of the optimizations and stuff that they have, right? So that pipelining and preparing those statements and pre-compiling query plans and everything works better when you have a long connection that lasts as opposed to short connections that come and go, which is the more mobile traffic, right? And so you have this layer in the middle. And I think the second critical reason behind that API server is security or authorization, which is that things and products that are running can't access those data systems directly because the business model of applications on the internet is based around centralized data and centralized logic. That's the business model of the internet, right? Of like Web 2.0, right? And let's not do crypto, but like the business model for the internet is that I have some centralized data and logic as a company, and I'm going to make that available, and I'm going to be the trusted source of this centralized data. And I'm going to make it available to all these users who are running in insecure private contexts, right? Like your device is your own. You technically, even if you don't like understand the machine, that code is yours. It's not running in the security context of the company. So your bank app, the code is insecure because the code is running with you. That has to communicate and run a transaction or do a thing, but that is centralized data, right? So that is centralized logic. So you're crossing this security boundary, right? You're crossing this boundary of like, somebody's requesting a thing and we don't trust them. You're converting that into an action that is trusted and saying, yep, we understand this action and we can go execute this action. So that authorization problem, and if you break down what authorization is, it's input validation. Somebody submitted a form. Is this form correct data? You don't trust it because it's coming from a form. Somebody's like filling in some junk there, right? Or somebody's being malicious. So you don't trust that input, so you validate it.
Give an example here. Like if you're listening at your computer, don't do this if you're in your car and unless you're at a red light or something. But actually, I don't know if you can do this on mobile anyways. If you're at your computer and you're listening to the show, you can go to any website right now. You can right click on anything and there's a button called inspect, and it'll take you to the code and you can go in and change it. Like you want to make Twitter, my Twitter, you could just go in. Now it won't show for anyone else, but for you it'll show. And you can even change what you send to Twitter or any website. Like you can send it literally anything you want. And so it's completely, in your control. It's your code. And so that's the problem is if you have now full access to the database, you could say, oh, hey, Chase Bank, I have $1 million now.
Exactly, right? And give me everybody's data and whatnot, right? So I remember one of those initial demos that we used to do to help people understand websites, right? It's like you open up like a popular website and then you go to like, you'd inspect element and you'd open up the HTML and then you go delete that HTML node and suddenly the website in front of you would change and you'd be like, oh,
Yeah.
the logo just disappeared. How did that happen? And then you're like, well, this is what it is, right? It's the code is sent to you and you're running the code in your context and it's your machine. It's your machine. This code is now running with your security context and you can own it and you can change it and you can do all sorts of wacko things with it, right? And so that this API layer is essentially at its core solving just two problems, right? It's solving this problem of arbitrating performance, and performance is like subtle, right? It's this concurrency issue. You have speed of flight issues. Your centralized database is in the US and then you have users in China and they're like, what? I'm like, the speed of light RTT itself is about like 180 milliseconds, right? And across the world twice, and you're like, I mean, it feels laggy, right? So you want to cache things that are closer to your users and stuff like that. There's like physics problems where you're still kind of restricted by this experience that you can have with the system. And so you have these kind of performance issues that you need to solve for. That's kind of one category. And the second category is essentially security and authorization validation. But in our minds, and our kind of hypothesis for building the company was saying, these are the only two problems that need to be solved. Everything else is just legacy. Everything else is people just doing things because they just do things.
Yeah, I mean that was one of the beauties behind the beautiful things about things like Next.js, where you're writing your front end back end server. So your front end API server is running the same code as your browser. And so, for example, otherwise you have this problem where we just talked about where you say, well, a username has to be 3 letters, but someone could just say, oh, I'm going to post a new username API with a 2 letter username. So, okay, now on the server, I have to say, okay, did this person disable the 3 letter check on their browser? And so the cool thing about things like Next is, you would have the same logic on front end and like literally the same code on front end and back end, but on the back end, no one could mess with it. But it's even with something like that, it's still a hassle that you have to think about everything twice.
Yep, exactly, right. You still have to think about it twice, and then when you think about like where's my security rule, is it enforced in the right place and whatnot, right? And so the idea then was to say if we wanted to automate API development and we wanted to automate this middle layer so that people can kind of go build products, including things like build it with Next.js or build it with serverless or build it with build apps, right? Go ahead and do that and use these managed data services that are continuously getting better. But this middle piece should just be automated. It should just be an implementation detail. It should be magic that exists. It's expected. It's an expected part of your infrastructure. And so what we did was we built an engine where if you can provide like a semantic model of how your data models become domain models, right? So you say that here's a user table inside this database and here's documents inside that database, and together they become a user model and a document model. Like they convert into logical models that you have that represent your domain. So if you can do the modeling, and to each of these models you can attach all the authorization rules that you'd ever need, whether it's input validation, who can access them, really complicated rules. Like you can say allow accessing a document if it's public, or if the current user is a collaborator, or if the current user is a family member of whoever owns the document, right? And there's hierarchical rules and there's all kinds of stuff. Then certain fields are hidden and masked, whatever, right? Like it's all just, we call it authorization. So if we have a nice system to model and to authorize those models, then we can just create the API automatically. This is the only domain-specific work that needs to be done. That's all you need to do. Nothing else should be written by hand, right? If we have this information about what your models are and how those models are secured, then we can generate the API that has pagination and ability to fetch from multiple sources in one shot, the ability to write data securely, the ability to read data securely, cache it, have HTTP level concurrency, do all kinds of things that you do by hand. But we can automate a whole chunk of that by saying that the user just needs to work at this meta layer, right? This domain layer. You think in models and you think about your domain and you don't do anything else. And so we built our own JSON API that does this. So we have like a metadata language, a domain specific language, a DSL, which is in JSON essentially. So it's like a JSON configuration. And in this JSON configuration, you provide the models and you provide authorization rules on those models. And you submit that to the Hasura engine. And the Hasura engine essentially just becomes the API. So instead of you writing code and then compiling that or running that inside an app server, Hasura is an existing app server that's already running, right? And then you just give it the configuration of your domain, the description of your domain and the models, the concrete description of your domains and models, and bam, we become the API. And we launched this in 2018. Open source became really popular. I think we went from like 2 million to 100 million to like 1 billion downloads over like the next few years. And that kind of brings us to today.
Yeah, this is awesome. So, I definitely want to know more about the authorization piece, but let's start from the foundation here. So, what you were talking about, you have either a website or a mobile app, and that app, transfers information to a backend server. And with something like Hasura, that backend server is auto-generated, but it's still running so that it can, make queries with an elevated permission, right? And so it's talking to the database. So, imagine a sort of mental model where you have front end, you have your front end server, and then you have your database. And you might even have back end servers if they have to do some complex thing like image processing or something like that. So that gap between the front end and the front end server, that gap is covered through HTTP calls. So you make an HTTP request, say log in, or you make an HTTP request, say get my profile. And if you're doing something with traditional REST, the way those look is actually not that different from the way a website works. Like you go to, google.com/search, and what you're going to get back is some HTML content, and your browser knows to render that as a website. Yeah, if you go to google.com slash, and I'm making this up, but slash API slash, foobar.json, then your browser is going to get some automated, some machine intended content, and it's going to render it again. Like maybe you'll get this, depending on your browser, you might get this nice UI where you can fold parts of the JSON and stuff. But you're effectively getting stuff that's meant for a machine. And so then, putting it all together, when you go to google.com/search, that HTML and that JavaScript will now have commands to get other websites, and those other websites are enriching that user interface with more data. So maybe the latest weather or something comes in through a separate call. And you can see all of those calls, if you go to the developer mode, but by default, you're only seeing that main website. Just under the hood, it's making all of these calls. And so, REST is the simplest. And is REST an acronym? I think it is, right?
Yeah, I think so. Representational state transfer, I think.
Oh, look at you. Nice. So REST is the sort of like canonical, like the version 1.0 way of doing this. And basically, you have query parameters. So, and this is just like a regular website. You do, question mark, A equals B, C equals D, E equals F. You also have a post body. So if you're making a post HTTP request, you could put a bunch of JSON or XML or whatever you want in the body, YAML if you want. That goes to a server. That server now has to, take the query and the body of your request, figure out what you intend to do there, and then it can return, some arbitrary information. So what is GraphQL? Why is it invented? What's wrong with REST? What is it doing better than all of that?
Yeah. So absolutely spot on, right? And then like when you kind of just build on top of that, remember when you mentioned that like when you have like a Google search page or something that comes in, you do have data sometimes coming in, not just from the primary Google server that surfaces like the search results, but you have like that weather information snippet thing coming in, right? And you have other pieces of information that are also required for that one page that you're viewing, right? And so what started happening was that as mobile applications became more complicated, we wanted to do more. We have the opportunity to have a richer experience for a user. and the user could see more, right, on their screen, and they could interact with it more. And when they wanted to see that information, right, you'd realize that you have to now hit multiple different machines and services and data sources to fetch that data, right? You are rendering a profile page, so you want to show the account information, but you also want to show the recent orders that this person has made, which might come from different services, right? Different API services or different data sources that are storing that information. Because remember, we're not in a place where we can store all of that data onto one single database, right? We are storing that in multiple sources of data. There's multiple ways of interacting with, there's different ways of interacting with these different sources of data and whatnot, right? And so when you're seeing that profile page on an e-commerce website, you're seeing that account information coming from one place, you're seeing your recent order activity coming in from one place, you're seeing your last 5 addresses, right? Saved cards, whatever. These are all like different sources of data that are then being unified into one thing. So what started happening was that people started getting frustrated with saying, I'm having to make too many API calls to fetch this information. And this frustration showed up in 2 ways, right? The first frustration was as a developer, when you were like, I can have one gigantic API call that fetches everything, right? Like, I'll build an API server that does this work for me. It goes and fetches all of the data in one shot and then returns this giant thing to me, right? And then this frustration showed up as like, every time I want a different slice of data, it's painful. So I'm on a mobile screen, I want to show you ID and name on the page. And I'm on a web screen, I want to show you ID, name, age, email, address, right? So I want to show you a different slice of data, because if I show you less data, I can transfer it faster, cheaper bandwidth, cheaper battery, faster experience. Or if I want to show it on your desktop screen, you typically have like a better internet connection. Your computer is more powerful. You have more real estate. You can show more data, right? Now, as a developer, when I'm building these products, every time I have a different like slice of the same data that I want to show, somebody has to go build a new API. Somebody has to build an API for 5 fields, for 100 fields, for 50 fields. It's a pain. Like, you have to build new API endpoints for each shape of your data that you want, right? That was kind of one frustration, right? The second piece that showed up then was when you're integrating multiple API calls into the building experience, it sucks. It really feels, it's terrible. It's like the worst part of building the product is integrating APIs, right? It's like you just want to build the product. You don't want to integrate APIs because an API is asynchronous. So you fetch data, you have to wait for it, then the screen loads up.
Yep, and you have to do something while you're waiting. You have to make the little loading spinner and everything.
Yeah, exactly. And so the only thing worse than an API call is multiple API calls, right? Because you're like, it's the only thing worse than having one API call on the thing that you want to build. You're like, God damn it, there's 50 now on this page, right? And so it's very frustrating. And so a bunch of people tried many different ways to address this issue, right?
Yeah, there was Meteor. That was a thing. Remember Meteor JS?
Correct. Meteor was a thing that tried to unify it around like a Mongo thing that the Apollo folks did. Then we had, I think the approach that was trying to create this backend for front end type situation was Falcor by the Netflix folks. Microsoft had something like OData. There's a whole bunch of like Microsoft SAP. There's a whole bunch of approaches. And then the Facebook folks created a specification for something called GraphQL, which was essentially a more structured way. It used a subset of the same concepts that we had in Rust. So you have like the intention is to say that you have a post method on a HTTP endpoint, but the post method now sends a query, a richer query that describes all of the things that you want. And the API server is now a more capable API server that can understand this query and fetch data from multiple places as required and then return that. So you're giving more control to the product builders and saying, you tell us what you want and we'll fetch it. So you tell us if you want a user and just the ID name, that's fine too. But you tell us that you want a user, ID name, last 5 addresses, last 5 orders, that's fine too. But all you have to do is send us one query on the API server, right? Kind of like a SQL for APIs, right? You don't go to a database and then you don't go to the database and you're like, hey, so give me one row from that table. Yeah, now give me one row here. And now do that. And now
Yeah.
You don't do that. You don't restfully interact with the database, right? You interact in a richer way like SQL. GraphQL brings that to the API layer, right? You're having a rich interaction with your APIs. You're fetching the slices of data that you want. And that kind of was the genesis of GraphQL. And it became an amazing API to consume for people who are building products. It was a lot more intuitive. I had to do slightly lesser work than integrating multiple endpoints. And I say slightly mildly, you had to do a lot lesser work when you had to integrate multiple endpoints. And the query language felt nicer. It felt like it's the part of the JSON that I want, right? So that's kind of what GraphQL is like. It's a specification. It's exactly like SQL is a spec, or REST is a spec, or gRPC is a spec. So it's just a spec, and that's what GraphQL was.
Yeah, that makes sense. So trying to tie back to Hasura here. So with the rest, you had a really good point, which is if I want to get my redacted profile or my profile with just my name, or I want to get my profile with my age. If I want to do this in one call, then I can have a query parameter that says return age, true or false. If it's true, then I get the age. And then if you take this to its logical limit, then it's like of everything I could return, in my request, I say, yes, give me the age. Yes, give me the name. Yes, give me the profile. No, don't give me the long description. And so, taken to its logical limit, you end up with something like GraphQL, where it's like, here's the things I want to return, and then everything else I don't want to return by definition.
Exactly.
And then, tying it back to authorization, the thing you have to really watch out for is if you're not careful, you might be able to say things like, give me Patrick's bank account. and so like with REST, because you're doing it, it's almost like you've seen this argument since assembly. Like there were those people way back in the day who said, oh, with assembly, I have all this extra control because I'm doing all this extra work. And that's true, but you pay for it in efficiency. But yeah, with REST, it's like you clearly see, if there's a API call that says, give bank account, you're begged to wonder like, okay, am I making sure I'm not getting everyone's bank account? But with GraphQL, you can end up with a blind spot where you accidentally allow someone to get someone else's information.
Exactly, right. And I think you have to be very careful in how you're building with GraphQL, because with great power comes great responsibility, right? Like you gave
Right.
more power to the front end developers or product developers, and then now you're like, whoops, somebody's going to absorb the complexity here, the increase in our footprint of being. If you're able to serve more, then you have to make sure that all the ways that this data is being served is secure. In REST, you control that, like as a API builder, like you decide that, well, there's 5 API calls. That's all you get. And so for these 5, I'm going to manually make sure that each of them is secure, right? But with GraphQL, the space is infinite, right? You can say, I want a little bit of this and then a little bit of that and then together, right? And I want like this and this and that, like A, B, and C together, but like bits away and bits away. So you're like fetching the data in a bunch of different ways, right? And so the surface area is larger. And the way that we think about it is everything should be model driven. We should separate the idea of the API protocol from the idea of the model. Because in your domain, what is important is the models that you have and the authorization rules are attached to the model. It is independent of what API, like what protocol is being used to interact with that model, right? So if I have a model and you have REST APIs to do CRUD, or you have a GraphQL API to query and subscribe and mutate, doesn't matter. The point is that the model has a description of what it is and what its fields are, and its authorization policies have a description of what valid input for this model is, or what valid ways to read it are for different kinds of users and roles, and what should be redacted and what should be masked or what should be encrypted, whatever, right? Like all of that is data associated with the model. Because once you put that close to the model, that's where your business is. So now when somebody wants to go review it and be like, what went wrong with like our users? Did we like leak information or whatever? You don't actually care about GraphQL or REST or gRPC or MQ, whatever, right? Like that doesn't matter. What you go do is you look at your model and you're like, I see what went wrong. Or, yep, I'm guaranteed that this actually works because my security rules here are okay. As long as these security rules are okay, who cares about what the API does? I can solve that problem like at a different layer.
Yeah, so in a way, REST can create this sort of landmine. Like, for example, you might say, get my bank account balance. And in my bank account balance REST call, I check to make sure that I'm me and I'm not getting someone else's balance. Then someone else comes along and says, get me my 10 most recent transactions. If he doesn't have that same logic, now you've exposed a hole. And so, like, if you have 100 REST APIs, all 100 need to share, and so you might as well just put this in a different layer to begin with, right?
Exactly, right? You might as well just do all of this at the model level, because what happens is that because the surface area is so small, you're tempted to put all of that in the controller logic, right? You say, oh, I have only 5 API endpoints. Why don't I secure each of them manually, right? And then before you know it, you're screwed because like the business keeps evolving and growing, right? And then now you're like, nobody can even think about it. Nobody can even answer that question, right? If like a security person comes in or product or business comes in and they're like, so how exactly are we securing this again? Nobody but a developer or two developers or like whoever wrote that old code, a new code, they all sit together, eyeball it, and then maybe they know what's going on.
Yeah, right. I'm surprised. Are there actually like things that sit in between SQL and I mean, I think Hasura has something. Are you sitting like is Hasura built on top of a model authorization library? Is that a thing? Okay.
So we invented it basically for ourselves, right? So we invented a modeling system and a policy language that allowed this to happen, right? And so that's what we built for our product. We said, if we can capture models and we can capture authorization rules on these models, right? And we're releasing this model and authorization system as a framework, and we're releasing this as a specification for the community at large so that anybody can use this specification to build services, right? And so Hasura uses this specification to provide an API. But technically, you can imagine where if I have the system that describes models and authorization rules, technically I can generate Rails code from it, or JavaScript code from it, or Java code or .NET. Doesn't matter, right? Because it's a concrete specification of what a model is and what the authorization rules are. So I can convert that concrete specification into any language or runtime that can then become the API. And so that's kind of what we're doing, and something that we're going to talk about at HasuraCon, where we're going to kind of release this internal spec that we have that makes this so easy. Because as a human, you just care about, here's the models, here's the authorization rules, now go figure it out. I don't actually care about details, right? Like, yeah, go write the Java code or whatever. Like, who cares? It's like, it's a shitty implementation detail I don't care about, right? Like, let it just run. But this is the concrete information that I care about. And this is going to take you 80, 90, 95% of the way, right?
How do you connect this with things like cookies and all of that? So if you want to know, like, okay, this you can access this information if you're logged in as this user. Now you have to like tie in cookies, maybe even Okta. Yeah, like how do you tie all of that together without being bound to one language, right?
Yeah, no, that's a really good question, right? So we separate authentication from authorization, right? And I mean, the industry does this as well, and then in our framework or like in our metadata, we do this as well, right? Where what we do is we tell users that in your authorization policies, you can always reference the current users or the current session's properties, right? So you always say in an authorization policy that allow access to this account if account.owner equal to current session.user ID, right? Or some property of the current session. So you can basically create complicated Boolean expressions, hierarchical rules that are essentially properties of the data, evaluate and properties of the session that are put together, and that expression is evaluated. That essentially is what determines whether you have the ability to access something or not, right? That's essentially what all your authorization code is. The piece where you convert a cookie or a token into the session information, that's a separate piece that you need to kind of specify as a mapping. The very nice thing is that, again, the industry has kind of realized over the last few years that a nice way to approach this problem is a JWT, a JSON Web Token. So if our cookie or if our header, our authorization header, contains a JSON Web Token, then a JSON Web Token is a secure contract, slightly painful compared to like vanilla EOD cookies from like 15 years ago, right? Those were much simpler. So the JWT adds a little more complex, significantly more complexity, but it's a common specification that everybody uses. Okta and Auth0, and Auth0 is Okta now, but everybody uses that JWT now. And the JWT is a secure way to pass on those claims of who the current session is. So in your authorization rules, when you're saying, I want the current session dot something, I want current session user ID, current session role, current session region, right? That's a contract that you can specify in your JSON Web Token. And you can say that my JWT is going to contain these claims. So use these claims to enforce some authorization policy, right? And then when you spin up your web servers, you give them the right keys to be able to decrypt and validate these JSON Web Tokens. So that's kind of the contract that we have, and that's what makes it easy for everybody to use, right? Like not just us, but like everybody in the world.
Got it. Okay, that makes sense. So you do provide like some the by you I mean the person using Hasura in this case provides some shim where they say, okay, here's some code that I know Hasura is going to run on server side. This code goes to Okta and verifies that this cookie is valid, and it gives me a list of groups they're in and their user ID and everything.
Exactly. In fact, with JWT, it's even simpler. You don't need to make that call. This is the reason why people really like JWTs, because with microservices, everybody realized that when a cookie is coming in, they're going to have to make this extra API call to validate that cookie. So people wanted to skip that step. So the JSON Web Token itself contains the user ID and information. It contains all of that information already. So you don't need to make an extra call to Okta. What you do instead is you have a key that Okta gives you to validate that the JSON Web Token was created by Okta in the first place. So that way, so it's like somebody sending you their user ID and saying, hey, I'm Tanmai. But then you're like, says who? Right? Like the API is like, you're saying that you're Tanmay, but are you really? Like, who told you? Like, who verified this? And then you can verify that signature and says, oh, Okta says you're Tanmay. Then you're like, yep, I have Okta's key, and so I trust this. So that's so you get to skip that extra lookup step. That's the detail with the JWT. That's the benefit that you get with the JWT. But to your point with Hasura, we support both of those modes. We support this JWT mode, and your second point, like your first point, we support the shim also, where you can provide us a piece of code where we can call out to you to do this lookup if it's a traditional cookie and not a JWT.
Is there a way in GraphQL to say, like, by default no one can see anything, and then to make it more of like a like an opt-in kind of setup?
Yeah, exactly. So it depends on how you're building your GraphQL API, right? So with Hasura, when you're building your GraphQL API, that's exactly the experience that we have, right? We're like, here are all the 10 data sources that you've connected, and especially in an enterprise environment, right? Like, here are the thousands of models that you have. Now, when you start that experience of building your GraphQL API, you start like creating domain models that are views of these models that you have, right? And then you start selectively bringing up those models and say that, yep, this is a part of my API, this is a part of my API, this is a part of my API. So then, like, you then decide to take a subset of that, the right set of that, transformations of that, or whatever, that then become your domain models, right? That actually help somebody who's building a product understand what this domain is about.
Yeah, I mean, it's a really interesting thing because my experience with GraphQL has been where there hasn't been this synergy, and so what you end up with is a GraphQL model and then one or more databases and they're not congruent. So it's like if someone comes in saying, hey, I want Tanmai's bank account. There's a certain structure that they're providing from the mobile or from the website, and then I, as the sort of front end back end developer, have to translate that structure into the database structure and say, oh, okay, actually, in this GraphQL request, there's users and users have bank balances, but in my database, there's actually banks and banks have users, and so like I have to manually do this, and it becomes very, very painful to have this sort of like dual understanding of the data at all times.
And that's exactly what the modeling layer has to solve for you, right? It's like you should be able to that decoupling, but keeping it cohesive, right? That's the work that you need to do at this modeling layer, which people call semantic modeling or semantic layer or whatever it is, right? But that's like essentially your model layer that describes your domain and maps it to the underlying physical sources that you have.
Yeah, but I mean, with something like this, you could do, you could have database views, and the database view is nice because it's very descriptive. It's like, okay, I have a table of banks. I have a bank table with user accounts in it, but I'm going to create a view called user bank, and the view like inverts that relationship, and then now my API is literally just authorized windows into that view, and now you have full traceability. There's not like Joe who mapped it from A to B in his head, and now Joe quit to join company X, right?
Yep, that's exactly it, right? And what we do at the Hasura level is that we make it easy for you to create these database views by creating those views in Hasura instead of having to create them in the database. So what happens oftentimes, especially in enterprise environments, is that you don't actually own the database because people are kind of scared to like say that, oh, somebody's going to come in here and do DDL on my database and create a new table or create a new view. So they sometimes don't want you to have that footprint in the database because it's really important. It's like if the database goes down, you're screwed, right? Like you're going to lose data, you're going to lose, like it's serious. So what you do instead is you create a view at the Hasura layer. And so you can create the same view at the Hasura layer, and then Hasura kind of pretends that this is a table. So when Hasura is compiling that GraphQL query into an underlying SQL query, Hasura is essentially like a just-in-time compiler. It takes a GraphQL query, it does a bunch of things, it understands the authorization rules, it compiles it into a SQL query. Like if you're fetching user banks, for example, it'll be like a select star from user bank where ID equal to current session.id. So it adds that where clause essentially, right? Because that's what your policy had. But it's not select star from user bank, it's select star from complicated logical model view, right? So when we're compiling it into the right thing that reflects what your data sources have. And then of course, because it's GraphQL, what you can also do is create relationships between models. So you can say, cool, I got this user bank model here, but user bank has city and city has weather. So I want to add weather to this user bank information, but the weather comes from an external API. So what Hasura allows you to do is create a relationship and says user bank has .city and .city is connected to the weather service. So because weather service exposes weather per city. And so now you can enrich that model. So now from a GraphQL point of view, you're getting user bank and then you're getting .city weather in one query. And these two models are connected. And Hasura is doing that work of figuring out, all right, you have a model here, you have a model here. There's a relationship. We'll do the work for you to figure out how to cache, compile, query, whatever, right? And that becomes very useful because again, you're just authorizing weather data, you're authorizing user bank information, you're creating semantic models, you're creating relationships. This is the work you want to do, and you get an API.
Very, very cool. Oh, one thing we should talk about is definitely like, there's a Hasura platform, but let's say folks want to use just vanilla GraphQL to get started. So someone might have a REST API, they might have a simple website they built, a REST API, a Node.js backend, and they say, oh, I think this GraphQL thing is perfect for me. How would you recommend people, learn about GraphQL and then port REST apps over? Like, what's your advice there? I'm sure you've done it a lot, have a lot of experience there.
Yeah, there's a bunch of things you can do. So I would recommend, so there's a bunch of learning resources that that the community maintains. So we have a bunch of open source tutorials that we maintain at hasura.io/learn, where you can go and kind of start playing around with GraphQL and getting a sense of what GraphQL is like, if it's going to be a good API for you and stuff like that. And that gets you started in like under a minute, basically. I think if you're building your own GraphQL API that is mapping to REST API services, you have a bunch of options. So there's a bunch of frameworks that are kind of helping you convert REST APIs into GraphQL natively, especially if you have an open API specification that you can convert. So Hasura does that. You can kind of bring in a REST API, create a GraphQL type for it, and get a GraphQL API. The other way, if you want to just like write that GraphQL server code yourself and get a feel for what it takes to build a GraphQL server. And once you do that, you'll never want to do it again because it's like
Yeah.
a server. Because it's good to do it, but you probably don't want to do it continuously, right? It's like it's similar to building a SQL server, right? Like nobody builds servers that speak SQL because you have
Right.
to. There's a query that comes in, you parse the query and you create a query plan and you optimize it, right? And you do all this work and then you're like, actually, I don't want to. I'll buy a database.
Yeah, or like compiling your own kernel or something. I mean,
Right. So you don't do, you typically want to kind of not do that work, but it's worth kind of doing that just to get a feel for it, right? And I think then depending on whatever programming language you're familiar with, you'll.
By the way, Patrick is twitching right now. As soon as I said compiling your own kernel is something you never want to do, I saw Patrick's eyebrow go up. Patrick is so just to give you some background time, Patrick's embedded software engineer of the two, and my code looks terrible by comparison.
Yeah. And he's like, why are people so scared of compiling their own kernels? You don't do it every day, right? Like, I do it for breakfast, then I do it for brunch.
You don't write compilers for your compilers that compile your code to code?
Exactly. right? So,
But yeah, I think to your point, GraphQL, like using like Apollo directly or something is good to do a couple of times, but
yeah, like for example, if you're using Node.js, Apollo has a bunch of libraries and there's a bunch of others. But you can do it then GraphQL has GraphQL Java, .NET has, I think, Chocolate, it's called Hot Chocolate. Every programming language has a bunch of frameworks. But I think once you do it once or twice, you will just be like, no,
yeah.
let's use a thing that helps us because I want a GraphQL API, the experience, and I already have these sources of data. Maybe they're like SaaS services, legacy REST services, databases, whatever it is, and I'd like a GraphQL API. So that's typically kind of the curve that we see as well, right? We see a lot of people kind of like using GraphQL and then running into like performance and observability issues, and then kind of saying that, okay, I would like to um, automate this layer because I like GraphQL, but the building of the GraphQL is a little bit painful.
That makes sense. So with something like Hasura that's kind of end to end, how do you deal with transactions, right? So if I need to, execute a handful of mutations and roll back if, it doesn't work, I know that, I mean, if I was writing this by hand, I would have a GraphQL mutation, and that mutation would have a ton of business logic that all is wrapped around a session, commit. Yeah, how do you handle stuff like that?
Yeah, yeah. So we do two things, right? So it depends. For example, if your transactions are simple, we support transactions over GraphQL itself. So you can run a sequence of mutations, and they'll all be all or nothing. So it'll all be like a sequence of like you can do create, read, update, delete, whatever, and it's a sequence, and you can execute that sequence in an all or nothing kind of way. This works only if each of those models are independently secured. It doesn't work if the transaction as a concept is centralized logic that can't be controlled, like a bank transaction. Like even if you secure each of the models inside, like accounts and transactions, you still can't allow a device to run that transaction from a user device. It has to be the user saying, run this transaction for me, and that code has to run in a centralized security context. So what we do for those are we allow users to have two common patterns. The first pattern is an event-driven pattern. So what we do is I don't know if you're familiar with CQRS or CQS as a pattern, basically command and query segregation, right?
No, I haven't heard of that.
So CQRS is a common pattern for like building and designing microservices and scaling them, where the idea is that you have a read model. So you have models that you can read from, and then you have something called a command model. And so what the command model does is that the user provides an input. The input is a command. And then that command then is an event that fires off a transaction that needs to run. That goes and does a bunch of things and updates a bunch of models and data models. And then you can read from the models that you've updated. So what Hasura does in this context is it's like a form submission, right? So somebody says, hey, I want to do a bank transaction. So that input comes to Hasura. Hasura validates that the input of the command is valid, right? Meaning that it's user A creating it, it's an integer, number, less than, whatever, some validation rules, right? And then Hasura just hands that off to a workflow system, a transactional system, an HTTP serverless function, a stored procedure inside an Oracle database, whatever it is, we don't care. We hand that off to something that runs your centralized logic, right? So we take care of the API contract that's coming in from the edge, and then we hand it off to some centralized logic, and we support a bunch that can run. And we do it over events so that it scales easily. That centralized logic does whatever it needs to do. And then when the output kind of comes to Hasura, we then enrich that output back into GraphQL. So you can say, do a bank transaction, and the output contains a reference to the account, and you can do a GraphQL query on the account. So you can fetch the account information and whatever has been updated. So this CQRS pattern is kind of what Hasura allows for. What we want to do is not interfere with business logic on either side. So we don't want to interfere with product business logic or centralized logic. So we just take care of the API contract, and then you write your logic however you want to write your logic. But you write your logic without caring about GraphQL. You write your logic just caring about what data systems you have.
That makes sense.
In complex enterprise environments, especially, what we see is your one mutation that has all the transaction logic also doesn't scale. Because what ends up happening is that this transaction is often a workflow across multiple services, right? Where you don't even get transaction semantics. Where what you need to do is do something like create user is like create user as a transaction on database one, send email, initialize
Right.
like data, right? Like it's like three different services that you need to hit. And so what people end up doing for that is they prefer a workflow engine to orchestrate across these services. And so then what Hasura helps you do is say, hey, we got the input for you and we validated it. And now as this workflow runs, you can actually subscribe to real-time updates on that workflow. So we often see this pattern. It's called a mutation subscription pair. So you send a mutation and then you get a workflow ID response and then you subscribe to that workflow ID. And then you'll see those updates coming in as your transaction executes across this workflow. And that's what you see in like a DoorDash when you're placing an order, right? Like you're seeing that kind of experience. So that's what Hasura does. Does that make sense?
Yeah, that totally makes sense. Yeah, no, it's a fantastic description. I think, I think it's a really good way of putting it. Basically, if it's something relatively small, like then it literally is a transaction that executes in kind of one round trip. Then you have ways to do that. But then to your point, most of the time you have these transactions, there's either a human in the loop, or if there's not, there's an external system in the loop. And so you don't really want to just block until it's all done. What you really want is just say, this is out the door, and I'll tell you. And basically things are inconsistent until we're done. So you might say like, go and spend all my money in my bank account. They say, okay, we're working on it. And then maybe, for that moment, you still have money in your bank account. But that's kind of to be expected, because the user experience is like, this isn't going to happen, in a microsecond. This is like a long running thing.
Exactly, right. And there's like all of the API issues are also often at this layer, right? So one of the common patterns here that becomes a pain is scaling writes is always a challenge, right? Because when you have a high volume of writes, like how do you scale that? And so what people typically do is they buffer it. So what you do is suddenly we had a spike of like 1 million events, like 1 million writes happened. So you don't actually try to make your database do 1 million transactions because it can't. And so what you do instead is you grab these 1 million events and you buffer them into a queue. And then the queue then outputs them at a throttled rate that your database can handle, right? So you tell people that, yep, I've gotten your order I've gotten your transaction request and we're processing it. Give us a sec. So you queue it up and you let the transactions happen over time. And the end user gets real-time visibility into like what's happening, right? They're like, yep, it's still processing or whatever. And then when it kind of finishes, right, or it gets taken up for processing, that's when the user gets to know. So like those kinds of things start happening, and that's what the Hasura layer does, right? Because that's the reason why everybody's saying that you want to have like event-based systems, right? You want to have event-driven systems. This is the idea, because a monolithic system can't scale.
Yeah, like even as we speak, they're still trying to liquidate NFT tokens. It's been going for about 6 months now, 24 hours a day, 7 days a week.
Yep,
And they're
yep.
still trying to sell those NFT tokens.
It's queued up. So,
Yeah, it's still in the queue. Oh man. No, this is awesome. So let's talk a little bit about Hasura. We talked about some things it can do. Let's talk a little bit about in terms of folks who are just getting started. Is there a free tier? High school students, college students. We have a lot of those folks listening to the podcast. Can they use Hasura for free? How does that work?
Yep, there's a free tier on our managed service. It's open source as well. So download the Docker image and start playing around with it. And there's a pretty generous free tier on our cloud service as well. So you don't need to download a Docker image and run it if you don't want to. We've partnered with Neon on the Postgres side as well. So that means that you have free tier Postgres as well. So, you can log into Hasura, create like a free tier Postgres and start actually building the API. And I think within a few minutes, you'll realize that you've probably saved like writing a week worth of code, because you're just creating models and getting your APIs. So that's one of the easiest ways to get started.
Very, very cool. And as far as Hasura, the company, where are you all based? Is it a remote first company, or if it's not, where are the offices, and what's it kind of like over there?
We're about 150 people spread across 5 continents, but we're kind of centered mostly around our HQ is San Francisco. And so we have folks in the Bay Area. And then we have another center in Bangalore in India, and that's another hub. So these are kind of the two hubs, and that's where most of the people are. But then otherwise, we're also fairly remote.
So I'm assuming Antarctica is out. And what is the sixth continent? Do you not have anyone in Australia or Africa? I feel like it could go either way.
No, we actually hold on. I think we're now in six then. North America, South America, Asia, Africa, Australia. Yeah, yeah, Europe. Yeah, that's true.
Wow, six. You just need to have someone in that South Pole office.
Yeah, exactly, right? I mean, it's just just a matter of time.
Yeah, that's right. No, that is very
So
cool. And are you all like looking to hire? Is it full-time interns?
we're always hiring, and so you'll see it on hasura.io/jobs or hasura.io/careers, or just follow our LinkedIn as well. And we're often hiring. We hire folks at all levels across a variety of roles: product engineering, go-to-market, which is marketing, sales. All of our roles are pretty technical, and so especially if you come from a technical background or want to enter technology, you're a developer and you want to build something for developers, that kind of thing is what we basically run on. And so keep an eye out on that and follow our LinkedIn. And we hire full-time folks, we hire interns as well. And so just kind of watch out for that.
Cool. What's the best way for people to get sort of noticed?
I think it's if you depends on what role you're applying for, but we really like it when you have experience with the domain and the product. So if you've built something with Hasura, and if it's like even if it's a toy application or it's a serious application or you build it at work or something like that, that's you just having that context is phenomenal for us. And whenever we see in our applications that people have kind of used Hasura or have experience with it or have or even in adjacent domains, right? Like for example, the database domain or the mobile web domain or the GraphQL domain, and have touched upon or built adjacent concepts that Hasura is built on. That's always great for us. So the way that you showcase that could be through a portfolio, a website, it could be through an application that you build, could be through a technical blog that you have. So just having a profile, and especially if that profile is immediately relevant or adjacent to what Hasura does, that's always very helpful for us to understand you and your application and then process that faster.
Yeah, that makes sense. Very cool. This is absolutely phenomenal. I wanted to ask you kind of one thing that we have on the show is we have a book of the show. And when we're doing interviews, we love to ask our interviewer what is their favorite book. Now, I know you haven't watched every episode. If you recommend a book we've already recommended, that's totally fine. But what is a book that you recommend, especially folks getting started in tech or people who are interested in GraphQL or just, it doesn't have to be super technical. But what's a book you'd recommend to people with that mindset?
I would say when it comes to kind of technology, like GraphQL like things, the best way is to just do. And so finding resources that are close to, like if you're like a Python developer, finding something that is close to the Python ecosystem and building that out and then kind of branching out from there is what I've found to be the most useful. And so I don't think I've ever read like a technology book since university.
No, sure. But like what's a book that, just for people who have that mindset, it could be, there's a book called The Hard Thing About Hard Things, I think
Oh
is what
yeah,
it's called, but it's
Ben Horowitz book. Yeah,
Ben Horowitz, yeah.
yeah.
So just what's a book that that kind of audience would appreciate that you've read recently or that you are really fond of?
I think a little more on kind of perhaps the leadership side of things. A book that I've really enjoyed, I think, is perhaps the best book on like business strategy that I've read is a book called Good Strategy, Bad Strategy. It's a short book. It's, I think, the only book on strategy that has actually made sense and is actionable and concrete.
Nice. I've heard about this book. I haven't read it, but you're the nth person to recommend it to me. So this is definitely I'm gonna have to check it out.
You should. It's amazing. It's a really nice read. And I think you can apply it at all levels of anytime you need to realize, anytime you feel like you want a strategy around something, right? Especially with a team, right? So it becomes really helpful for all of that. And it's surprising because most books on strategy are useful during peacetime and not wartime. Um, so peacetime, wartime is like, I think it's from the Ben Horowitz, Hard Things About Hard Things.
Right,
Yes,
right.
that description of peacetime, wartime, right? So most strategy books are very like peacetime descriptions of like, oh, everything is going along well and you need to improve something. And so let's create a strategy around it or whatever. But I found good strategy, bad strategy to be really good, even like we need to get something done in 3 months or we'll die. Or, we need to do something over 4 years. And it's a big transformation that's going to take time. So that's a book I've really, really enjoyed.
Very, very cool. Yeah, it looks like the author is Richard Rumley. I don't know if that's French or if it's Rumlet, but yeah, very cool. Yeah, we'll put it in the show notes and folks can check it out. Thanks a lot for suggesting that. I think it's, I've heard many good things about that book. So
it's a short book too, which is nice.
Yeah, totally. Yeah, it looks like, let me see if I can get the page count here. It says it's 11 hours on audio, which is, yeah, pretty. Oh, here we go, 300 pages. So yeah, it's not bad at all. You could knock that out in a weekend. Cool. This was amazing. I think we covered GraphQL in great depth. I'm a huge GraphQL fan. I think, I have seen in previous companies people accidentally expose things in GraphQL because it is so powerful, and that is always something to be concerned of, which is why, again, having some kind of authorization, as we talked about, is extremely important. But provided you get that right, it's one of these things that becomes more and more important as you go along. And so if you start off on the right foot, it's much easier to keep running. It's much harder when you have 300 REST calls and 40 different clients to have to move over to GraphQL. So it's good to learn these things, off the bat. I love how we kind of dovetailed into, how do we connect the model into this, the database. Really phenomenal. And thank you so much, Tanmai, for having the time to spend with us here today.
Likewise, it was a super fun conversation. And, for folks as well, feel free to reach out to me if you want to chat about data or GraphQL or APIs and product stuff. So I'm always around.
Yeah, definitely. We'll put it out in the notes, but just to put in the show, do you have a particular way that you like to be reached out to? Is it Twitter, LinkedIn?
Twitter's better, LinkedIn's also fine.
Okay, very cool. Yeah, we'll put it in the show notes. So if you're listening on just about any podcast app, you should be able to swipe right. And unlike getting like a Tinder girlfriend or something, you'll actually get the show notes and you can go and click on our Twitter handle. You can click on the Programming Throwdown page. You get the notes in HTML. You can also support the show on Patreon, which we really appreciate. We take all of the donations from the show and we use it to improve the show and also bring new people. We've brought a lot of new folks into Programming Throwdown, and it's just so great. There's actually an email Patrick and I got today from somebody who learned C++ for the first time, is just getting started, and that always kind of fills our cup, warms our spirit. So we really appreciate that, and appreciate you, Tanmai, for coming on this show, and look forward to catching up in the future.
Likewise, thanks a lot for having me.
Music by Eric Barndollar.
Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.